Good afternoon. This is Mr. Singel, and today we're going to be talking about the difference between chemical and physical changes. So as you probably remember from class, physical and chemical changes are things that you can observe. They are what happens when you do an experiment. Physical changes are things that do not change the chemical composition of your test subject. Chemical changes do change the chemical composition. So, for example, if I react sodium metal with chlorine gas, it'll make sodium chloride, which is commonly known as table salt. This would be a chemical change because sodium chloride is not the same chemical as sodium and chlorine. On the other hand, if I evaporate some water, that water goes into the air as water vapor. It's still water, even though it's not in its liquid form. So, that has been a physical change. So let's take a look at how we can tell whether a change was chemical or physical. In order to tell the difference, we're going to use this handy acronym. That is EPOCH. There are 5 different things that we're going to look for that'll tell you whether a change was chemical or physical. The first letter is E, and it stands for a pretty hard word, effervescence. Effervescence means bubbling. So anytime that you do something to your test subject and bubbles start to appear, that would be one hint that you might have a chemical reaction. Our next letter is P. P stands for precipitate. A precipitate is any time that you have something that was dissolved in a liquid, but it becomes a solid. So you mix 2 things together and a solid forms when there wasn't one before. It's a little bit hard to come up with good examples for this one without doing some actual chemistry, but there are lots of reactions where, for example, you'll mix some silver nitrate with some hydrochloric acid, and as a result you'll get some silver that comes out of the solution, and you can see it as a white powder. Usually precipitates will take the form of a white powder. Our next letter is O. O stands for odor, or more specifically, odor change. So anytime that the smell that you're getting off of a chemical changes, that's going to be a hint that there is a chemical reaction that happened. For example, a marshmallow on its own doesn't smell much like anything, a little bit like a marshmallow, whereas a cooked or even a burned marshmallow is going to have a very distinct smell that you can probably bring to your mind right now. That would be a hint that your marshmallow has changed in some way chemically. Our next letter, C, stands for color change. We can use our marshmallow again for this one. Your uncooked marshmallow is going to be pretty much just a blank white marshmallow. But once you roast it over a fire, it's going to start turning brown, and if you leave it too long, it's going to turn black. That would be a good sign that there was a chemical change. And finally, our last letter, H, stands for heat. So heat in this case would be represented by a change in temperature. When you release energy from a chemical by doing a chemical reaction, it's going to release some heat. This is easy to see when you burn some wood. The bonds that hold together the different components of the wood break apart, and they contain a lot of energy. So when they break apart, they're going to release that energy in the form of heat that you can feel as, fire. So having any one of these things present is not a guarantee that it's going to be a chemical reaction, but it is a pretty good hint. When you have more than one present, it's going to start to be pretty clear that there is a chemical reaction. So, for example, if there is an odor change, that may be a hint on its own, but if you also see a color change, like with our marshmallow, that would almost guarantee that there was some kind of chemical reaction that took place. This is important because chemistry deals mostly with chemical reactions, as you can probably tell from the name.